So it'd be very nice, once we do this, not to tear up the machine and talk about how we can sweeten it without doing any much work at all. Watch the big spike. Next. Fine, we'll go back. So we got the answers already. There they are. You've seen it. Next. And we can simulate. We can still do this. The one on the right is the one we want to do. Smooth and conversion. Or not. Next.
Play that one again.
Go back.
It's more important than the T-Rex.
Well, you do remember the
5 times it makes a bigger sound.
a robot this size should be running as fast as you've seen the treadmill go, times 2.
You have this model running.
Well, that's what we want to build next.
So explain that. Explain what that is. You made that, didn't you, Chris?
Chris, go ahead.
Well, this was kind of illustrating the concept of using the hip torque to shift the ground reaction force to point towards that metacenter. So,
While you explain it, I'll get the prototype.
so in the last prototype, they're both the same model. Right now, there's a little bit of a passive torque due to the torsion spring unloading, because you can see it swinging forward and then kind of bottoming out and then matching ground speed and unloading. But then there's, in this sim, there's actually active torque.
So just constantly.
Well, yeah, just kind of feed forward.
But you're not doing the math to actually constrain the force to be along the line. It's just kind of a simple control.
No, I actually am calculating.
Okay, so you figure out what it could be.
But we're hoping that we can sort of play with the fast parameters that still pass by that.
And as far as try to continue it down for a second.
All right, but you get the idea.
As far as handling accelerations and that, and just like some marginal level of control, is that done by shifting the metacenter relative to the center of mass, or that's kind of
We just kept the coordinates on the hip because the CG can't move except around that arc anyway. And the idea is we can tune a cam that might be slightly nonlinear just to make sure that what we want happens. So we're investigating, can we make that entirely passive at all ranges of speeds by tuning the spring profile in a cam to make sure that happens using the alignment to metacenter as criterion. And the first test we did using alignment to metacenter as criterion gave us that, and the torque came out to be what it was. And it was smooth and it worked. So it's 1 o'clock. We got about 2, 3, 5 more minutes for questions. Anything you want to go back to? Basically, a robot this size should be running 20 miles an hour.
If it's 4 more times, it makes jiggle sound.
I don't know what it does. But we'll make one this size and make it run at those speeds. That's what I want to do in the next 30 days. Next. That's what we're building. For its size, even though you might be able to see the legs going twice a second, in dimensionless center of gravity terms, because there's no time for the center of gravity to accelerate at all, barely, in a single stance, then we're going at these dimensionless speeds for that size. Next. That's visualizing geometric stability for highway speed, high dimensionless velocity, bipedal locomotion design, and it works for whatever you got. Next. That's us. Thank you.
what's the next step?
That's what we said we'd discuss. So